We're moving along now. We're on number 11, and it says Emily made 14 out of 19 shots during basketball practice, right? About what percent of her shots did she make? Explain your reasoning. So we know she made 14 out of 19, right? So 14, like when you get a test score and it's out of 10, we say you got 5 out of 10, you would put 5 over 10, right? Same idea here, 14 out of 19. So one thing you can do is go in and out and use your calculator and divide. It's on my old answer from before. So I could say 14, right? This goes inside, this goes outside. So divided by 19. Now to get this, 0.73. And I would move this over, 1, 2, and that would be 0.74, right? If I round up, which is the same as 74%. So which one of these is closest to 74%? That would be 70, right? The other way you can do it, if you don't have a calculator handy and you wanted to do it, the other way is to think, well, because it gives us a way out right here. It says about what percent. Oops. So about what percent means it has to be an estimate. It has to be close to. So that means 19 is almost 20, right? And we know percents are always out of what? Say it with me. Percents are out of 100. So I can think, if this is, oops, let's say 14 out of 20, or let's say make it 15, it's an easier number to work with. Well, then I would say 20 times what equals 100? Well, times 5. And if I do times 5 here, well, what's 15 times 5? Well, 15 times 2 is 30, which means 15 times 4 is 60, plus another 15 is 75, right? So 15 times 5 equals 75. And I'm doing all that in my head. And again, I get 75 over 100. So this is my percent that's close to 20. Or I'm sorry, close to 75%, because 75 out of 100 means 75%. And which one of these is close to 75%? That would be this one, right? The only one that's, oops, I thought I had my circle. The only one that's close to 70% is this one, or 75% is 70. That's the closest number to it. So that's how we do number 11. Those two ways you can solve that one. The more precise way is to do 14 divided by 19. Okay. All right, so it says a muffin recipe calls for a ratio of 5 cups of flour to 2 cups of sugar, right? So 5 cups of flour to 2 cups of sugar. For each cup of sugar that is used, how many cups of flour are needed? All right, so let's write this out. We have 5 cups of flour, right? And 2 cups of sugar. Oops. So that's what it's given us. For every 5 flour, there's 2 sugar. So now it's saying for each cup of sugar that is used, how many cups of flours are needed? So now it's telling me sugar. So now let's say our sugar is going to equal 1, right? Because it says for each cup, and each cup means 1 cup. So for each 1 cup of sugar, how much flour is going to be used? So now I have to think, how did I go from 2 to 1? What did I do? Well, all I did was I divided by 2, right? So if I divide 2 by 2, I get 1. So if I divide 5 by 2, I would get a number, which is 5 divided by 2, right? And that would be cups of flour up here. Now you can actually work it out and say 5 divided by 2 equals whatever decimal shows up for that, 2.5. But we don't need to do that because that isn't an answer choice here. There's no decimals. So we know 5 divided by 2, or 5. There you go, cups of flour. That's going to be your answer. All right, 13 says the line graph shows the number of members during the first few months of the photography club. Describe the data, then predict the number of members for the 6th month. So if we want to describe the data, what are we noticing is happening? Look, this is the number of members, and this is how many months have happened. So the first month they had just under 4 people. At 2 months they had, in between 4 and 8, which is about 6, right? They had almost 6 people. At 3 months they had maybe 7. At 4 months they had more than 8, right? So we're knowing that we're seeing that they're going up, right? Numbers are constantly going up. So at 5 months, they're at just under 12, which would be probably 11, right? That's what's happening at 5 months. So it wants to know, predict, if the numbers are going up and they're already at 11, so at the 6 months, what do you think is going to happen? The number's going to be above 12, right? So what number or what answer choice is above 12? That's how we're going to do number 13. All right, so the table shows the number of points Anna scored this season. Find the mean number of points Anna scored. So this is how many points she scored during all these games, right? 12, 16, 12, 7, 6, 11, 9, 8, 12, 10, 15, 14. So what we have to do is when we're dealing with data, I mean, you could put it in order, but since we're finding the mean, it doesn't really matter in this situation. I mean, it matters if we're doing mode and median, but it doesn't really matter for our mean. So what you can do, remember we have to find our average. You're going to add all these numbers together. I know there's a lot of them. And then you can divide by however many games she played. So let's count the games. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means I'm going to have to say 12. I'm taking this number now. 12 plus 16 plus 12 plus 7 plus 6 plus 11 plus 9. Oops, that was not a 9. Plus 8 plus 12 plus 10 plus 15 plus 14, right? Whatever number that equals, I'm going to divide it by however many games I have. So let's count again. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all this divided by 12 is going to be my answer. So take the sum of this divided by 12. Good luck. That's how you find your mean on this one. All right, it says Albert purchased, I'm skipping to 16 now. Albert purchased 2.4 pounds of mixed nuts for $4.79 per pound. How much did he spend in all? So if I'm doing 4.79 for 1 pound, right? Because it says per pound right here. Per pound means per 1 pound. So it's $4.79 for 1 pound. But they didn't buy 1 pound, they bought 2.4 pounds, right? And let me put pounds on here. Okay. And this was dollars. Oops. So we have to think of our relationships here. And that's what's so cool about math. A lot of times that's all it takes is to figure out our relationships here. So from 1 to 2.4, what am I multiplying by? I know I'm just multiplying by 2.4, right? Which means if I multiply this by 2.4, I'm going to have my answer. Whatever that answer is going to be up here. 4.79 times 2.4. You can either work it out, which we would love for you to do, or you can use a calculator and take the quick way out. That's number 16. So number 20 says the line plot shows the quiz scores of several students. Someone scored a 5, or one person scored a 5, one person scored a 6. 2 people scored a 10. So remember, your range is your maximum subtracted by your minimum. So what's your biggest number subtracted by your smallest number? All right, so Julio is evaluating the expression below. Which operation should be performed first according to the order of operation? This is where you have to remember PEMDAS. Parentheses, exponents, multiplication or division, addition or subtraction, right? And remember, these are whichever comes first, as are these. Right? So we have to think, are there any parentheses? Well, there are. It's right here, 9 minus 4. So which one of these talks about what's happening in the parentheses? Is it adding 6 and 2? No, right? Is it multiplying 2 by 9? Which would be right here. No. Is it subtracting 4 from 9? Yeah, right? 9 minus 4. So that's what we're going to do there. That's your answer for number 21. For number 22, it asks you lost my mouse. Oh, here it goes. Which property is represented by the equation shown below? 6 times 3 equals 3 times 6. So which one of those is shows what that would be, right? 6 times 3 is the same as 3 times 6. So then you just figure that out. You can actually Google each of those and see which one shows up. All right, we're going to number 23 now. It says the algebra map below models the equation. So this little diagram here, says that something minus 2 equals 4. So what would that something be? Right? This should be pretty easy for you guys to figure out. What number would go here? Instead of x, we would put a number. All right, number 24 is a little tricky because I don't think we really talked about this one. But it's saying graph the figure with the vertices 2, -1. So there's one right here, right? Oh no, it's right here. 2, -1 would be like right here. Then 6, -1, which is all the way over here. Then 6, 4, which would be right here. So when it goes straight up like that, we know it's a right triangle, right? And then, so what shape is this? So I'm just gonna complete my shape. Now we know that this going up is like 1, 2. Sorry. Oh, it should have been up more. I guess -1's right here. So I actually messed that up a little bit because of the way this line is. So -1 right here because this is 0, right? Yeah. So I'm sorry, it should be right here to 6. And then up here to 4. There we go. Fixed it. So I know the number of units is 1, 2, 3, 4, right? So this is 4. And this is 1, 2, 3, 4, 5. This side is 5. And then this one I don't really know because there's a bunch of different ones in there. It's hard to tell, right? But 1, 2, 3, 4, 5. I don't know what it is because there's like half squares and stuff in there. So since all these sides are different, that means it's a scaling triangle. And since this goes straight up, I know this is a right triangle. So that means it's going to be a scaling right scaling triangle. That's what our answer is for this one. I know it's kind of tricky, but that's what it is for number 24. I don't think we really talked about that much in class, which is why I did it. All right, 25 says, which number line shows the solution to the inequality x plus 3 is less than or greater than, less than or equal to 1. So now we have to solve for it. If we have x plus 3, and let's just pretend that's an equal sign, right? Instead of that, instead of the less than or equal to 1. So how would I solve this? Well, I need to get x by itself. I need to isolate the variable, which means I'm going to subtract whatever's next to my x, right? So I'm going to do the opposite of plus 3, which is minus 3. Oh, I see a problem here. We haven't talked about negatives with you guys. Well, let me solve it this way. I don't think we've talked about, this is a 7th grade standard here. But we have x equals, and 1 minus 3. So if I have $1 and I paid $3, and I had to pay $3 for something, that means I owe someone $2, right? Which is minus 2. So x is, and instead of equal to, I'm going to put this guy right here, less than or equal to. I'm copying my symbol back, which was this guy. So let me bring it back over here. X is less than or equal to -2. Now, when we solve that, we're going to go to the -2 spot first, which is right here, right? This is -2. There's a dot here, so it could be this one, or it could be this one. But we know x is less than or equal to -2. And since it's an equal to, it has to be a closed dot. Well, this is closed dot, and this is the closed dot, so it can still be either A or C. Now let's think, what's a number that's less than -2? -2 is like you owe $2. So what would be worse than owing $2? That would be owing $3, right? So -3 would be a number that's less than -2. And -3 is on this side, so we know it's going to go in this way. So our answer is C. And I know, again, this one is one that we haven't really covered in 6th grade. It's more of a 7th grade standard, so I worked this one out for you guys too. All right, that is it for today. I may work on more tomorrow. If not, join a Zoom, ask questions and comments, and I'll help solve some of these guys for you. Have a good one.